Hello everyone, welcome to my channel Physics with NK Bhatt. To learn concepts of physics, subscribe this channel and press the bell icon button to get notified for every new video lecture. Good morning dear students. In the last video lecture, we discussed about the intensity of fringes obtained in Young's double slit experiment. In today's video lecture, we will talk about the another phenomenon, that is diffraction of light. So far in the wave optics, we discussed about the Huygens principle or construction, refraction and reflection of plane wavefront, coherent and incoherent sources, and interference of light. This phenomenon is also related to the wave optics. Diffraction is the phenomenon of bending of waves at the edges of obstacle that you can see in the text. Also here I have written the bending phenomenon. We discussed about the optics so far are refraction and reflection, but the reason behind those bendings are different, and here the reason behind the bending is different. If the wave is propagating from one place to another place, and during its propagation, if any obstacle comes in between, then it is found the wave is bent at the edges of the obstacle. This phenomenon is diffraction. The very first and foremost thing about diffraction to understand is under what condition the diffraction occurs. That is the very major part of diffraction. The condition for diffraction to take place is the size of obstacle must be comparable to the wavelength of the wave. This is the condition for diffraction to take place, and that is what the size of obstacle must be comparable to the wavelength of the wave. If this condition is not satisfied, then diffraction will not take place. To understand this condition in detail, I take the example of light and sound. We know that the wavelength of light is very short. It is shorter than micrometer. It is of order of nanometer, that is 10 power minus 9 meter. So if we talk about diffraction of light to happen, then we should have the obstacle whose size is comparable to the order of 10 power minus 9 meter. So such a small obstacle physically is very difficult to have. So the diffraction of light is not a common phenomenon. On the other hand, if we talk about sound, the wavelength of sound is quite large, and we have so many obstacles of comparable of the wavelength of sound. For sound, diffraction is a common phenomenon. For an example, if we talk about a big wall and a person is standing on one side of the wall, if the person shouts, then his voice reaches to the other side also. Why it is happening? Just because of bending of the sound wave at the edges of the top level of the wall. On the other hand, if the person is using torch in his or her hand, then light of torch will not reach to the other side. Why? Because light is not bending at the edges of the obstacle. So this bending is possible for the light if the obstacle is comparable in size to the wavelength of the light. So this example illustrates us that for light, diffraction is not seen commonly, but for the sound it is experienced commonly. Just see this diagram. If we talk about the diffraction, this is the wave propagating from one place to another place, and in between there is an obstacle. If this wave passes over the obstacle, then the waves are bent and entering to the opposite side in large area of view. This region is known as geometrical shadow region, in which the light is sprayed after the diffraction, or you can say any wave which is getting diffracted is sprayed into the geometrical region of the obstacle. So for light, this is not possible for such a big size of obstacle because wavelength of light is very short. To understand the diffraction of light, we have one another aspect, that is slit. In the last section of this wave optics, we discussed about interference, and we had used two slit experiment there, that is Young's double slit experiment. So in which we had used two slits, and the waves originated from those two slits are interfering and produced a pattern on the screen. The same we are having here, that is single slit. The diffraction we can understand in the laboratory by using a single slit. So it all depends on the width of the slit. You can see I have taken two diagrams here having two slits. One is quite wide and other one is narrow slit. You can visualize and compare these two diagrams, that in the first diagram the bending is quite less, in the second diagram the bending is quite large, and that we can see that the light is spread into the opposite side in large area of view. So the region behind this slit is known as geometrical shadow region, in which the light is entering. Here also you should keep in mind that the size of slit, that is width of the slit, should be comparable to the wavelength of the light. Then only this bending will take place, or we can say the diffraction will take place. If this area is less, then definitely the spreading of light would be in more area. So we have seen two diagrams here. One is having wide slit and other one is having narrow slit. So I hope it's clear that the condition necessary for diffraction to take place is very important, and that should be taken care of when we talk about the diffraction to take place. So in conclusion, we can say that at single slit, if size of the slit is comparable to the wavelength of light, then after diffraction, light enters in the geometrical shadow region of the slit. This is about the diffraction at single slit. I hope you understood the fundamental concept of diffraction, the condition necessary for diffraction to take place. In the next video lecture, we will discuss in detail about the diffraction at single slit. Thanks for watching this video. Keep watching, keep learning.